Now that we have discussed graphing straightforward equations, it is time to turn our discussions to practical uses of these ideas. We will use the same major ideas, but at a couple of other points as we progress through this video. Here's an applied problem. The cost of running a certain business is $100 a day plus $5 for every calculator that is produced. If Y represents the daily cost and X represents the number of calculators produced, write an equation relating X and Y. Then, graph the equation, showing at least 3 different possible answers. So, the first thing we are asked to do is we are asked to write an equation relating X to Y. And it says here that Y represents the daily cost. So, for my equation, I'm going to have the daily cost is equal to, and it says X represents the number of calculators produced, and they cost $5 for every calculator. So it would be $5 times every calculator that is produced, plus it says another $100 just for opening up. So an equation relating X to Y could be written Y equals 5X plus 100. Then it tells me that I should graph the equation, giving at least 3 different possible answers. This particular equation is written in slope-intercept form, and when we talked about slope-intercept form, we said that there were really a couple of different ways that we could graph it. One way to graph it would be to set up a table of values and go through and figure out some points. Now, since this is an applied problem, one thing I would also do is I would say what the Y is equal to and what the X is equal to in my table. Y, it says, is the daily cost. So I'm going to put that down, not just the Y, but the daily cost, and X is the number of calculators. Now, certainly I could have a business that does not open on a particular day, and I could have produced 0 calculators then on that day. If that's the case, I still have a $100 on a daily cost per day, so if X is equal to 0, Y is 100. And I could also go through and say X is equal to 1, but this is where we need to start talking about the practicality. It probably does not make any sense to open up a business and just produce 1 calculator, so instead I'm going to use X is equal to 100. Whatever number I choose there would certainly be to your discretion, but I'm going to choose 100. If X is equal to 100, then Y is equal to 600, putting 100 into that equation. And then I'm going to try 200. If X is equal to 200, then Y would be equal to 1,100. So I do have now 3 different possible answers that would work, and now I need to work on graphing the equation. In order to save time, I already constructed this graph, but I want to point out some very important things. First of all, it is very important that you go through, I think, and that you label the axes. And notice that I went through and I labeled both of the axes at the very beginning so that I know exactly what each of them mean. Second, you have to determine a scale that works for both axes. Notice that for my X scale, I decided to count by 25s. Now, I did that knowing that I had to get up to at least 200, but I certainly did not need to count by hundreds. If I did, my graph would be fairly small. For my Y, I decided to count by 100s because I knew that for my Y, I had to get all the way up to 1100. It is very important to realize that the scales do not need to be the same, and they also don't have to start with 0. Even though both of these ones do. Then what I did once I came up with my scales is I just plotted my points. So my first point that I have plotted is that 0, 100 point. And you can see that I have that right here. I just went over it in the blue. And then I plotted the point 100, 600. And I plotted the point 200, 100, or 200, 1,100. And I drew my straight line. And that leads to the third point. In most practical problems, you won't have arrows at both ends, and you may not have arrows at all. It does not make any sense to have an arrow at this end. Having an arrow at that end would indicate that I would be making a negative number of calculators. And in this problem, that just does not make any sense whatsoever. I want to point out one other thing as well. When we were graphing equations that were written in slope-intercept form, I had said to you that you could go through and you could set up a t-chart, or you could go through and you could put a dot at the y-intercept and then use the slope. And certainly that would work as well. Notice that the y-intercept for this is 100, and that is where I have this particular point at 0, 100. The slope of this is 5, so I need to go up 5 and over 1. But since I am counting by 100s going up this way, I could go up 500, and then if I went up 500, I would be at the 600 mark right here, and then go over 100, because the ratio 500 to 100 is the same as the ratio of 5 to 1. Sometimes when doing practical problems, it just makes more sense to go through and set up a t-chart rather than to go through and do the slope-intercept type method of doing it, but certainly the slope-intercept method does work. Here's another practical problem, and this one is solved by creating a standard form equation. Mr. Harris is taking his drama class to see a play. Tickets cost either $15 or $20. He has $240 to spend on tickets. If X is the number of $15 tickets he buys, and Y is the number of $20 tickets he buys, write an equation relating X and Y. Then graph the equation, showing at least 3 different possible answers. You can see here that I've gone through and I have already written a possible equation. If there are $15 tickets, and X is the number of $15 tickets, and there's also $20 tickets, and Y is the number of $20 tickets, I'm going to add 15X plus 20Y, and it has to equal 240 because that's the amount of money that he has. Since this equation is written in standard form, the way to go through and graph this is first of all to set up that table of values. And once again, as I go through, I'm going to set up X and Y, but I'm probably going to go through and say this is the number of $15 tickets, and the Y is the number of $20 tickets, just to make sure I have everything down here correctly, and then go through and say that if X is equal to 0, what is Y? If X is equal to 0, that means Y would be 12, doing the math. And if Y is equal to 0, then X would equal 16. So I am ready now to go through and graph that. Once again, for the sake of time, I've already gone through and graphed this, but I do want to point out a couple of things. Notice that I did go through and label the axes. The number of $15 seats is on the X, the number of $20 seats is on the Y. And then I also determined my scale. For this particular one, I really could count by ones for both the X and the Y, so you can see that. And now I put in my points. So my first point is the point 012, so I have a dot at 012. I also have a dot at 16,0. And then I went through and I connected those points. Now, when I connected those points, I also ended up going through these other points as well. And certainly, those are other points then that satisfies. This particular point is the point 12, 3. So 12 $15 seats and 3 $20 seats would work. This is the point 8, 6, so 8 $15 seats and 6 $20 seats would work. And this is the point 4, 9. So 4 $15 seats and 9 $20 seats would work as well. I'd like to point out a couple of other things with this problem also. Let's look at the slope of this particular problem. The slope of this particular line, I am going up 12 and I am going to the left 16, which is a negative 16. So the slope for this particular problem is actually a negative 12 sixteenths. Now, certainly if I wanted to, I could give that another name by dividing by 4 over 4. A slope of negative 12 sixteenths is the same thing as the slope of negative 3/4. And notice that that does work. If I go up 3 and over 4 to the left, I'll get to this point. If I go up 3 and over 4 to the left, I'll get to that point. And up 3 and over 4 to the left, and I will get to that point. So I can still use that idea of slope to find these other points. Another thing to point out for this is that notice that there are not any arrows on this particular line. It would not make any sense to put arrows on either end. Putting arrows on both of those ends would mean that at one point I would have a negative number of $20 seats, or I would have a negative number of $15 seats, and that does not make any sense. And then the final thing to point out is that realize that not every single point on this particular line satisfies necessarily this practical problem. I could figure out what the coordinates of this particular point are that I just diagrammed, but it looks like it is about 10.5 for the x. Well, for this practical problem, it doesn't make any sense for Mr. Harris to go and buy 10.5 $15 seats. So not every single point on this particular line satisfies this particular problem, although every single point on this line will satisfy the equation as it's written. Here's a third type of practical problem that we can do by graphing. Suppose the demand for a certain video game is 2,000 units when the price is $55, but only 1,500 units when the price is $75. Let Y represent the number of video games demanded and X the price. Graph the two ordered pair described, draw a line through the points, and then use the line to estimate what the demand would be if the price dropped to $40. In this problem, there is not an equation that is asked for. Instead, you are to plot the two ordered pair that are described and use the line you create to help you make a determination. The two ordered pair are 55 2,000 and 75 1,500. And you can see that I put those in a T-chart with the price and demand for the X and the Y labels as well. So on the next slide, I will have drawn a line with those two ordered pair shown. Based on the information known, this might be a graph that would work. First of all, once again, notice that I did go through and I did label my axes, price for the X and demand for the Y. And notice that what my scales are. For the X, I decided to count by 5s. And I counted by 5s because I have to get up to 75, and I thought I could do that. But on the Y's, there's no way I could have counted by 5s. I decided to count by 250 because I knew I had to get to at least 2,000 as far as the Y's go. The question said, use the line after I plot the points. So the very first thing I did is I went through and I plotted the points. Here's the point 55 2,000. Here's the point 75 1,500. And I just took a straight edge and drew a straight line all the way through. The question says, use that line to estimate what the demand would be if the price dropped to 40. Well, you can see right here is the $40 mark. So if I follow that straight up, I'm going to be at this particular point on the line. And if I carry that over to check what the demand is, it looks like the demand is somewhere a little bit higher than 2,250. So I might estimate the demand to be about 2,300 if the price is $40. Doing practical problems with graphing is something you will be doing in other courses as well, like accounting and economics. You will also get plenty of more practice with graphing applied problems in the rest of this course. As always, if you have any questions, please make sure that you ask.